the last week of classes. Since the last week of lecture. Are you guys excited? No, me neither. I'm sad. It went by too fast, and I feel like I had like so much more to give, right? So Monday, you guys are doing next Monday. You guys are doing your presentations next Monday. Okay. Thursday. Next Thursday is a field trip to Santa Barbara, UC Santa Barbara. So if you're interested in getting some extra credit points, I'm going to need you to fill out this form and plan a field trip next Thursday. Anybody interested in getting a couple of extra credit points at the end of the semester and taking a field trip to UC Santa Barbara? Please fill those out. The ASAP so that you guys will have a spot. We have 50. What else? We have 50 seats available. And then the date is the 15th. Yeah, 16th, sorry, 16th. So next Wednesday is your final. Technically, it should be Saturday. Is technically the last day that I can give you your final. Your final, you guys have an option. You guys want to do it face to face, get it done, you knock that away, or do you guys want to do that? You guys have to decide since nobody else is here. So if we do it face to face, it'll be on Wednesday. If we do it online, then you guys will have till Saturday at 11:59 p.m. to get it done. That's when the class will officially close. So there are, I think there's 60 questions, 60, 65 questions for your final, all multiple choice. Oh, now everybody comes in, actually we'll get some more. We were just talking about you too. So your ears burning? Okay, so real recap. So we classes. Oh, sorry. Class officially ends next week, not this weekend, but next week at 11:59 p.m. So we are deciding whether or not you guys want to take your final in person, or do you guys want to take it online? Okay, but you'll have until 11:59 p.m. on Saturday to get it done.
Next Saturday.
Not this Saturday, but next Saturday. Okay, so I'll give you guys the opportunity to think about it for a minute. There's also a field trip, not this Thursday, but next Thursday on the 16th. And I'll give extra credit points for you guys towards your final. You guys attend. It's going to UC Santa Barbara. So if you're interested, you have to sign a permission slip or a waiver, social waiver. Anybody interested? Anybody who came in later interested?
Yeah. So.
Shall I want to? Interested? Okay. Interested? No? Okay. Good. So next Monday, you guys have your presentation. You guys ready? Well, you better get ready. It's next Monday. Next Monday. So you guys have the first 3 presentations. then you guys will be following up with some other presentations. Also on Monday, we're gonna do a little bit of a potluck, it'll be a pre-Thanksgiving a brunch potluck, so it'll be breakfast or lunch type items. I'll be bringing ham, so. Let's see, what else? On Monday. So we'll be eating while we're being entertained by your presentations. You guys have any questions? Why are you laughing when I said I'll be bringing ham? Why is she laughing? What was so funny about me bringing ham? I'm not allowed to bring ham. Yes. Let's see, what else? You guys know Friday is a holiday. Or no, it is Veterans Day. It's the observation, so you won't have, you shouldn't have any classes on Friday. And I typically won't have any homework that's gonna be due on Friday. So, let's see, what else? I will be opening up all your homework assignments and all your lab assignments so that you guys can upload things that you might have not uploaded. They'll be open until next, not this Saturday, but next Saturday when class officially ends. Okay, so I will do a review. I'll probably do a review this Saturday for your final. Or what we can do is that, so the students in my other class, they have the option of signing up after you guys do. So there's 3 groups here. So we'll do your 3 groups and then we'll do their groups. And then we can do an hour review if you guys want to do that on Monday, next Monday. Or Wednesday, we can do another review. I'll leave that to you. Yeah, we'll still do it Wednesday. Since you guys are gonna take your exam, instead of taking it in person, you guys will take it online, if that's the case. What do you guys think? Or we can do it on Monday, and then you guys can take the exam on Wednesday, and then you'll be done with the exam. Nothing else to worry about. No? You wanna do it online? So 1 for online. So those who want it online, raise your hand. Those who want it face-to-face, raise your hand. Okay, so I guess online it is. Okay. What was that? Okay, so for those who don't have a copy of the practice exam, I'll get you one in a few minutes after we take our break. Let's go ahead and get started. Okay, so calculate the molar mass of calcium chloride. Okay, so we need to write down what we have. So we have how many calciums? What is the chemical formula for calcium chloride? Calcium chloride. One calcium, 2 chloride. Ca2. Okay, so we have 1 calcium and 2 fluorides. Okay, how much is calcium? Then we have 2 fluorides. And then how much is our fluoride today? Multiply that times 2. So
37.9.
37.99. So then we're going to add them together. What are the units? Grams. Okay, piece of cake. Everybody got it? Good, good. Okay, so if we take a look at this figure here. We'll take a look at this figure here. This here, all of these elements in the first figure, figure A, all of those elements have 1 mole of that element. So we have 1 mole of iron, we have 1 mole of aluminum, we have 1 mole of mercury, we have 1 mole of nitrogen. Right? So all of those represent having 1 mole of each of those elements. Now you'll notice that they all have different masses, and that makes sense. Because let's say if we have apples, we have 5 apples, right? And then we have 5 grapes. Would we expect those 5 apples and those 5 grapes to be exactly the same? Okay, so you're not going to expect 2 elements to be exactly the same if you have the same quantity, because they all have different associates. Okay, so and that's the same thing with compounds. And you'll also notice that they occupy a different amount of space, each one of them. Okay, so you're carrying out a laboratory reaction that requires 0.0360 moles of barium chloride. How many grams of the compound can you measure out? Okay, so we're given the number of moles, and we want to get the number of grams, right? So what are we going to use to go from moles to grams? The idea is? What's that? Okay. I didn't ask you if we're going to use what mathematical expression. What are we going to use that you know of to do that conversion? Smart ass.
We're gonna get the weight that we, or the mole that we already have, and multiply by the sum of the barium chloride.
What is that called? The sum of the barium chloride. What is it called?
Like, I don't remember the name of it.
You don't remember the name of it?
Yeah, like, that's all. Like, I know we have to do that. So
That we just did, but you need to know those names. Come on, help me out. What did we just do? We're going to multiply by the molar mass. Molar mass. Okay, so what is the molar mass? How do we calculate the molar mass for barium chloride? What is the chemical formula for barium chloride? Okay, so then how many bariums do we have? We have one barium. And how many chlorides do we have? Barium weighs? 137.33. And then chloride weighs? 35.45. And then there's two of them.
Yeah.
What's that? Gmols. Okay, so you're saying we're gonna multiply it by the molar mass. So if we have 0.036 moles of barium chloride. And we want to get to grams, so we're going to put grams on top or on bottom. Okay, so our moles of barium chloride are going to cancel out, and then we're just going to be left with grams of barium chloride. What do you guys get?
It's 7.
7.50. So why is it 3 sig figs? Because we started out with 3 sig figs. Okay. Okay, questions? Concerns? Cash? Kool-Aid? Cockroaches? See if you're paying attention. Okay, I can move on. Everybody got it down? Well, you were just too busy talking. Okay, not high school. You guys have, this is it. This is the last week of like, last week, that's it, okay? So, we need to step up, let's get to this, so we can start getting some of stuff done. I know you guys want to talk to each other, wait till after class, or wait for the break, okay? I know it's important to talk about that board, right? Wait till later. Okay. So, when we're talking about the mold, right? You guys remember what the mold is? What is the mold house? Mold. Tells us what? Not the little animal that comes up the ground, that's not the one I'm talking about. It's funny, you guys are quiet.
It's a math, it's a mold math.
Molar mass, well, so we're using the molar mass, but what is the mold? What does it represent? Well, it's based upon carbon 12, that's right. It's based upon carbon 12, good job. Remember that, that's good. What else? What else? The isotope carbon 12.
The weight of that one.
So the mole doesn't give us the weight, right? It doesn't give us the mass either. Weight and mass are kind of comparable. What does it give us? What was that? Well, one mole represents Avogadro's number, that's true, but what does that represent? What was that? Elaborate, give me a little bit more detail. You make it simple for me, but, you know, I'm having a hard time.
Is it like?
Said GMC? What is GMC? You wrote it down over there, I don't know what GMC is. Isn't that a company or something? Yeah. It's a truck, right? I'm like, damn, you guys talk about trucks? What is it? What does that mole represent? What does that mole represent? No, not mole fraction. It doesn't represent mass, right? We know it doesn't represent mass. If we're talking about just the mole, not molar mass. Because molar mass is the way to convert from grams to moles, right? It's grams per mole, right? It's conversion moles. So then what is it? Can you compare, how many bottles are on your table?
4.
Okay, 4. What does that number represent? Say it again. It represents a quantity, right? So we know that the moles are going to represent a quantity. When we make reference to a unit, that represents a quantity, right? That's how many we have. So if I have 6.022 times 10 to the 23rd, right? I know that that's 1 mole, right? Kind of like I know that 1 dozen is 12, right? Those are quantities, okay? So if I'm given my quantity, then I'm going to use Avogadro's number to get to the number of moles, right? And then if I'm given my number of moles, I can use the molar mass to get to the grams. Okay, but we need to know what we're starting off with. Is it quantity? Is it moles? Or is it grams? Because you can't use all of them all at the same time, right? And we also need to know what it is that we want. Okay, because then that's going to decide what we're going to use. So if I have quantity, units, atoms, electrons, molecules, formula units, right? Any of those, I know that I'm going to be using what? To do my conversion to get to moles. Said earlier over here. They said it over here. This thing. What am I going to use? Avogadro's number. That's right. We're going to use Avogadro's number. So if I'm given moles and I want to get grams, what am I going to use? The molar mass. Okay? So you want to make sure that you understand what you're looking for, what you're starting with, and what you're looking for. Because otherwise you waste a lot of time. Okay? How many of you guys know how to bake a cake? Yeah, we're still waiting on that damn cake, right? It's been how long? Well, I'll say that. What? 3 months, almost 3 months, right? She actually don't think about us. We're important enough, okay? So, if we think about baking a cake, right? So let's break it down. What is, and I'll put it on the board here. What is our generic recipe? You said flour. Let's do simple. You know, we're working on a budget. Okay. So we have to get now, are you getting this down? So we can get that cake eventually. You get it, write it down. Okay, so we have cake mix. And you said, how many eggs? 3 eggs. Milk? How much milk? 2 cups? That was a cup and a half. You eyeball it? That would explain your case too, huh? Sure there. Let us find out. Bring it. I dare you. Okay. What else? Salt. So usually cake mix already has that. We usually don't add the salt. Oil or butter, right? So let's do a stick and a half of butter. A whole stick. A whole stick. Okay, and then that's gonna make 1 cake, right? 1 cake. Okay. Now, this is our recipe, right? Now let's say 1 cake feeds 5 people, right? Okay, 1 cake feeds 5 people. And we have 15 people in this class. So we should have 15 people in the class. We may not have 15 people in this class. Actually, we have 16 people in this class. So we have 16 people in this class. How many cakes do we need to make? 3? So somebody ain't gonna get a piece of cake? She's like, nope, you just don't get a piece. How many of the slice? Oh, of course, because you're mean. You're rude, if I remember correctly, right? So we ain't gonna do extra, right? We ain't gonna do that 1 extra. How many cakes should we make? 4. So we should make 4 cakes if we 16 per slices, right? So if we're gonna scale up for that, what do we need to do? Multiply what? Multiply the ingredients by 4. So if we know how much we need to make, we can sit there and use a multiplication to sit there and determine how much of each of the items that we need. So we can go shopping and get everything that we need, right? We do this all the time. Don't you guys do this when you cook? Like you have a whole bunch of people coming over, you're like, yeah, I need about 5 of these, and you know, right? Or if you're feeding for a family of 5, don't you scale up, right? Chemistry is just this, right? Once you have the chemical equation, the first thing that you need to do is get a balanced chemical equation. We just got a balanced chemical equation, right? So we know the ratio of cake mix for every 1 cake mix, we need to make 1 cake. So if we need 4 cake mixes or 4 cakes, we need 4 cake mixes, right? We also know the ratio of eggs, right? So for every 1 cake, I need 3 eggs. So if I'm making 4 cakes, how many eggs do I need? I need 12, okay? So once you have a balanced chemical equation, you can sit there and calculate how much you need of whatever you're looking for. But the first thing that you need to do is to have what? Just say. We need what? We need, the first thing that we have to do is get a what? I'll say it again. Once you have a balanced chemical equation, right? You're able to sit there and calculate how much you need, right? Okay, so what is it that you should have first? Say it one more time. Now I want you guys to say it over here because you look at it like you're crazy. A balanced chemical equation. And I want you to say it over here. What do we need? Balanced chemical. Okay. And what do we need? You're gonna make that cake for us. So you gotta make something better. Okay. So we need a balanced chemical equation. So once you got a balanced chemical equation, we can go through the process of using stoichiometry to figure out how much we actually need of each of the different items, right? If we want to do that. Okay, so let's go through that process of stoichiometry. Okay, so if we're given mass, we need to change it to moles because we know that our balanced chemical equation, particularly this one, is based upon what? What's it based upon? Is it based upon mass and we go out and weigh the number of grams that we have in each thing? We did? On that. So if we weigh a pound of cake mix or a grams of cake mixes, is that what we did? No. So what is it based upon? Amount or quantity, right? So we know it's based upon quantity, right? So we need to know that we have to change it to moles first. To be able to use the chemical equation, we have to change it to moles first. So if we're given mass, then what do we need to do for that mass? We're given mass. What do we need to do for that mass? I'll say it one more time. If I'm given mass, what do I need to do? What did I say I need to do? I need to convert it to what? I need to convert it to moles because moles are quantity, right? So if I'm given grams, I need to convert it to moles. How do I do that? No, not without Gauss number. If I wanted to convert quantity to moles, I use Avogadro's number. What packet? Want that packet? $755. Let me see if I have a copy of it. I'll have to. Anybody else need a packet? Nobody else? You do? Okay.
You use those.
Okay? So what are we gonna use to convert from mass to moles? No, we just said it. She just said that. No, you guys don't listen to each other either. It makes me feel good. At least you're not just not listening to me, you're not listening to each other either. So it's not Avogadro's number, because we only use Avogadro's number if we have quantity and we want to convert to moles. Okay? So I'll say that again. We use Avogadro's number when we want to convert quantity to moles. Okay? So what are we going to use if I want to go from mass to moles? Say it again. Molar mass. It makes sense. If I'm going from grams to moles, I'm going to use molar mass, right? Because the units are per mole, right? Okay. So we want to sit there and think about what we're doing. What is it asking for, right? What is it that we need? Okay. Okay, determine the mass in grams of 3.2 times 10 to the 24 molecules of sulfur tetrachloride. First thing that we're going to do is do what? I would say we should probably figure out what chemical we're working with. Right? So, what is the chemical formula for sulfur tetrachloride?
1 sulfur and 4 fluoride.
Set 1 sulfur. Okay. So we know the chemical formula is SF4. So we have 1 sulfur and 4 fluorides. Okay, sulfur weighs 32.06. And fluoride weighs 18. And there's 4 of them. And that's going to be you got 108. That's for both of them added together. So 108 point. Okay. But we're starting off with molecules. So yeah, 3.2 times 10 to the 24th molecules as our starting point. So what am I going to do? That's molecules. This is grams per mole. Avogadro's number? So I'm going to use Avogadro's number. That is correct. So we know that we have 6.022 times 10 to the 23rd molecules. And that's going to be 1 mole. Okay, so then that's gonna give me my moles, but I want grams. So what else am I gonna need to do? Okay, okay. My final answer. What do you guys get?
I don't know if it's right, but I feel like I think it's
You got 574?
Yeah.
So then how many sig figs should we have? We should have, how many? Two. So then the answer should be 570. Okay? Okay, did everybody get that down? Yes, because how many sig figs do we have? We have two sig figs. Two sig figs, right? So since we have two sig figs, our answer has to have two sig figs. Because otherwise it'd be 574 point, I think 23 or something like that. 574.1720. So we only have two significant figures, so we only need to have two significant figures in our answers.
It has ends some, but it has a ends.
Okay, so the next thing that we're gonna talk about is percent mass composition. Percent mass composition. Okay, so when we talk about percent mass composition, we're gonna be looking at taking the part over the whole. Okay, so if we're talking about a chemical compound, and we wanna know how much of one of the elements that we have in our chemical compound based upon mass, we're gonna use that molar mass to help us determine it. So for instance, if we have the, we want to calculate the percent mass of fluorine in calcium fluoride, then I'm going to use my calcium fluoride as my whole, and I'm just going to use how much fluoride I have, okay? So what is the chemical formula for calcium fluoride again? CaF2. Okay, and that means we have how many calciums? We have one calcium. Calcium weighs and then we have how many fluorides? We have two fluorides. Fluoride weighs multiply that times 2. And we're going to add that together. It weighs how much altogether? So 8 point. You said what? 7.4. Okay. Grams per mole. Okay, so then that's going to be our total, right, of the entire thing. And then if we're looking at just the fluoride, how much does just the fluoride weigh? $37.99. Okay, so 37.996 over 78.074. And we're going to multiply that times 100 because we want percentage. And so if you guys do that math, You guys end up with.
48.
Should it be? We're gonna round, yeah, okay. So 48.7%. Okay, so then that would be a fluoride, right? So what would be the calcium? How could I do the calcium?
Just change this for right.
So I'll just put on top, I could do it that way, that's true. So I could have just put 40.078 divided by 78.074 times 100. And what do you end up with? What did you guys end up with? $51.3. So I could have also just, since there's only 2 elements in that compound, I could have just subtracted from 100%, 48.8. I mean, 48.7, sorry. And then that would give me the remainder. Okay? Could have just subtracted from 100%, 48.7, and then that would give me my remainder. So if I have only one other element, because it has to add up to 100%, I believe.
Could you do the same for the multiple elements?
If there's multiple, yeah, you have to do 2 of them already, and then that last one you can subtract from. Okay, okay, everybody got that? Okay. Okay, calculate the percent mass of aluminum sulfate. So I want the percent mass of each of the elements in aluminum sulfate. So I'll let you guys do that and we'll grab your packets. Okay, you guys ready? What's that? You said no? Can I give you a break after we do this? You gotta earn the break. Gimme got shot. Got shot. Gimme got shot. Can you give me a break? And I said, in other words, no, I'm not giving you a break. You can earn a break. Gimme got shot. Never mind. Okay, so what is the chemical formula? What is the first thing I should do? Write down the chemical formula. Okay, so what is the chemical formula? Al2, parentheses, SO4. Okay. Okay. So how many aluminum do we have? We have 2 aluminum. And aluminum weighs 26.98. 982. And we're multiplying it by 2. Okay, how many sulfurs do we have? sulfur weighs
32.6.
we're multiplying that by 3. And then oxygen, how many oxygens do we have? And oxygen weighs 15?
16.
Sure. Is that at 15.999?
Oh, yeah, 32.9.
Times 12. Okay, so let's do that math. Okay, so if I want the percent mass of aluminum, how would I calculate that?
4 divided by 15.6.
Times 100. Okay, what about the sulfur? Okay, and then the oxygen.
Get the total percent and subtract it by 100.
You mean 100 minus
Yes.
the 15.8 minus your 28.1. Okay, good job. Okay, so let's go ahead and take a short 10-minute break. I'll see you guys back here at 9:33. 9:35. I'll give it to you.
Why is it charged on the oxygen?
Because we know that we have 100%, that's the most we can have, right? And so, next question. Aluminum chloride is 38.35% chloride. What is the mass of aluminum chloride? What mass of aluminum chloride is needed as a source of 50.0 milligrams of chloride? Give you guys a second. No, it's gonna be. What was that? Yes, you have to. Yes, we will be taking roll. You guys decided to it's gonna be on. Next Wednesday or this Wednesday? Okay. We're doing this. Okay, so where are we going to start? Okay, chemical formula. So let's write down the chemical formula. So what is the chemical formula? So it's Al2. Are you okay. Al. Okay. I'm writing down what you tell me. Okay. And then chlorate. Okay, I actually have done my project on the chart because somebody want to help her out? Chlorate. O. How many O's? Three. Okay, what is the charge on chlorate? Negative. Okay. And then what is the charge on aluminum? Positive what? Positive 3. Okay. So if we have a positive 3, and we know that chlorate is a negative 1. So then how many chlorates am I going to need to balance out my aluminum? Okay, I'm going to need 3. So it should be Al parentheses ClO3. Okay? Okay, so that's good. So what else are we going to need to do? First off, what is the percent mass is what again? What's the equation that we use for percent mass?
your amount over total time.
Okay, so it would be the mass of my. So mass of my chloride in this case. Okay, which we know what it is, yeah, over mass of what? Is it of aluminum?
Total.
The total, so it'd be the aluminum chloride. Times 100. And then that's gonna equal my percent mass for aluminum, or percent mass for chloride. Okay, so isn't that given to me, the percent mass of chloride? Okay, so I can put that in, 38.35%. And then that's gonna be equal to, so we have the mass of our chloride, okay, which is 50.0 grams. So then all we need to do is calculate our mass of our aluminum chloride. Okay, so how can I do that? So I want to isolate my mass of aluminum chloride. How can I get that isolated? Okay, breaking down the equation. So what do I need to do to both sides of the equation? To try to get it so that I just have my mass of my aluminum chloride by itself. How about multiplying both sides by the mass of the aluminum chloride? Both sides of the equation. What was that? But you don't know the mass of it. You don't know it's 100, so you're just multiplying it by it. So you get rid of this, right? That'll cancel out. And then you divide both sides by your 38.3%. So then,
Oh, I thought you were gonna divide the score by itself, but.
okay, so then we're ending up with just a mass. And then that's gonna be 50 times 100 divided by 38. Not percent,
But it's partial.
because they're asking for the mass, right? So this here represents the percent, percent's gonna cancel each other out, right? And then, so you're gonna end with 130. What was that? How many sig figs should we have? How many sig figs should we have? How many sig figs? Are you sure? How many's here? 3, and then how many's here? So with multiplication and division, so then how do I choose? Am I gonna choose the 3 or am I gonna choose the 4? The 3, why? That's right, we choose the one that has the least amount, right? So then we choose the one that has 3, so it'll be just 130 with our decimal, so we let you know that that 0 counts and it's grams. Because mass is grams, right? So that should be your answer. Oh, you're right, it's milligrams, my bad. Milligrams, that's milligrams. Correct. So it should be milligrams. Good eye. Okay, so let's move forward. Okay, so we talked about percent mass composition, right? So this is also going to be kind of important for us to kind of understand when we're talking about compounds, the makeup of compounds, okay? So when we talk about the empirical formula, we're making reference to, do you guys know what the empirical formula is? Let's start out with that. So the empirical formula represents the simplest form that we can get a chemical equation in. So for instance, if I have C6, H12, O6. So the empirical formula for this would be the one that we can get to that we still have whole numbers and get it to its simplest terms, right? So in other words, if I divide everything by 6 here, right, that would give me C, H2, and O. So that would be the empirical formula. Okay, so you want to get it into its simplest form or its simplest term. So that would represent its empirical formula. So if I have C4, H10, what would be the empirical formula for that? C2, H5. So it's the case where you can have a whole number and still, you know, to the lowest form, so you can't divide it by anything else.
Why do you take away the simplest one?
We want the empirical formula. So the empirical formula is just, it's gonna be the simplest form. So what happens, and a lot of times in chemistry, we'll use a piece of equipment and the equipment will give you the empirical formula. It won't give you the molecular formula. So like for instance, if it's looking at sugar, it won't give me C6H12O6. It will give me the number of carbons in relation to the number of hydrogens in relation to the number of oxygens. So it will give me the simplest form. So it will give me CH2O. Okay, and so that would be the empirical formula. Okay, so often you will end up getting an empirical formula from an instrument. And so you're using the empirical formula, then you're going to have to try to figure out what is the molecular formula. And I'll show you how to do that here in a minute. Okay. Okay, so the way that you can do your empirical formula, the first thing that you always want to do is you want to convert your masses into moles. Mass always has to be converted to moles because we're looking at the mole-mole ratio of the atoms to each other. We're looking at the quantity related to each other. Okay, so we always have to change that mass into moles. Then once we do that, then we're going to divide it by the one that has the smallest number. Right? So once you get into moles, the one with the smallest number, you're going to divide everything by that number. Okay, and then that should give you your empirical formula. Now, sometimes you may end up with a number, let's say you divide it by the smallest number, one of your numbers has a fraction, right? So it'll be like 1.5. In that case, you're gonna have to multiply it by a number to get a whole number. Okay, and I'll show you an example of that. Okay. So if we have a pure compound is made up of 1.61 grams of phosphorus and 2.98 grams of fluoride, find the empirical formula of the compound. Okay, first thing that we have to do is, what units are grams? What type of units are grams?
Oh, no, okay.
Okay, give me more. They're more than just a metric. What do they represent? Mass, okay? So we have mass. So what are we gonna have to do since we know that we have mass? We have to change it to moles. So if I have if I have 1.61 grams of phosphorus, symbol for phosphorus, okay. So the symbol for phosphorus, symbol B, okay. And then you're telling me that it weighs how much? 30.974. Okay. So is that going to be on top or on bottom? 30.974. And that's grams on the bottom here. So then my grams are going to cancel out. And then I have one mole on top. How many stick figs should we have? Should have 3. So if I have 5, 0.05197908 moles. So what should the answer be? If I have 3 stick figs. Okay, and then it tells us we have 2.98 grams of fluorine. What is the symbol for fluorine? F. How much does fluorine weigh? That's grams. So that one, let's put one mole on top. Okay, so how many sig figs here? Great, so my answer should be, okay. Okay, so which number is smallest? Phosphorus. So we're gonna divide both of them by phosphorus. Which is 0.0520. Okay. This is gonna be 1. So we have 1 phosphorus. And then correctly. And it has to, if it's close to a whole number, so for instance, this one is 3.0165, right? So if this number is 1 or 0, then we just round up, we round it to this number, right? So then it will just be 3. So, because we can only have whole numbers here, right? So then that means our empirical formula is going to be P(F)(3). So that would be the empirical formula. Okay? Now, if this number here was, let's say, a 3.2 or a 3.33 or a 3.5, if it's a 3.25, a 3.66, 3.75. So if it's any of those numbers here, right, or close to those numbers, then in this case, what we would do is we multiply it by what would give me a whole number by multiplying this 0.2 by what number? That would give me 1. 0.2 multiplied by what will equal 1? 0.2 times what equals 1? If I have 20 cents, how many 20 cents do I need to make a dollar? I'll need 5. So I multiply this by 5, that will give me a whole number. Okay. If I multiply this number by what? I have a quarter. How many quarters will make a dollar? 3 quarters make a dollar? 4. Well, you can work for me. I'm gonna use you, 3 quarters make a dollar, don't worry. Okay?
I thought you were counting the 25 already.
No, you multiply it, right? So, if I have 33 cents, how many 33 cents will make a dollar, or close to a dollar? 3. So in this case, we just multiply by 3, because that will get us close enough, right? 3. Now, if I have 50 cents, what do I need to multiply? 2. Okay, so if I have .667, what do I need to multiply it by to get a whole number? So if I have 1.667, what do I need to multiply it by to get a whole number? Or close to a whole number? Try multiplying it by 3. It'll actually get you close to actually 2 point, yep. Okay, if I have 0.75, what do I need to multiply that by to get a whole number? Give me 2, actually. Number 2. What's that? 2? Not 2. So 4 times, because if you went by 2, that would give you 150, right? So if we just go 0.75, I'm going to erase this first number so you guys can look at just the fraction part of it. So 75 cents times 2 is what? 150, right? Is that a whole number? Is that is even close? Yeah, you're trying to get whole numbers, yes. So the purpose is to make these into whole numbers. What do I need to multiply to make this into a whole number? Okay, so if I have 0.8, what do I need to multiply it by to get a whole number? 5. See the trend? 5, 4, 3, 2, and then 3. So as you go to the other side. Okay? Okay. Okay, so nicotine is 74.1% carbon, 8.64% hydrogen, and 17.3% nitrogen. And this is by mass. Okay. What is the empirical formula? What do you guys think we're going to do here? If this is by mass, what is an assumption that we can make? We could change it to moles. Okay. That's true, but first thing is this is percent mass. So then what are we going to do? How are we going to change that to moles? So we have to make one assumption first. That's right. So we're going to assume that we have 100 grams of our compound, right? So if we have 100 grams of our compound, that basically means that we have 74 grams of carbon, 74.1 grams of carbon. That means that we have 8.64 grams of hydrogen. And then we have 17.4 grams, 17.3 grams of nitrogen. Okay, so then how do I change that to moles? Molar mass. So we're going to divide it by its molar mass. What is the molar mass of carbon? 12.011. That's grams per 1 mole. Okay, what is the mass of hydrogen? One point zero zero eight. And what is the mass of nitrogen? Fourteen point zero zero seven. Okay, so what am I gonna do next? We're gonna divide it by the smallest one. That's right. Okay, smallest one is. Okay, 1.24. So that's gonna be one nitrogen. Okay, so this number is close enough to, if I have to round it up, the whole number. And then this one. So is that close enough to? So then my chemical formula or my empirical formula is gonna be B5, H7, N. Okay, questions? Everybody get it down? Okay, so if we're trying to find a molecular formula, let's say we're given the empirical formula and we're given the molar mass, we can calculate the molar mass of the empirical formula and divide that by the molecular formula's molar mass. Okay, and then that'll give us a whole number, and we multiply that whole number by the empirical formula, and that will give us our molecular formula. Let me show you what. A compound with the empirical formula C2H5 has a molar mass of 58.12 grams per mole. So in this case, this is what the molecule, the real molecule's molar mass is. This is our empirical formula. So then we can calculate the molar mass of our empirical formula. So how many carbons do we have in C2H5? We have 2 carbons. Carbon weighs 24, 0.022. And then it has how many hydrogens? 5 hydrogens. The hydrogens weigh 1.008 times 5. Okay. Okay. So then we add those together. $29. Grams per mole. So then we take this value here. (8.12 grams). And we divide it by our empirical formula. And you get approximately 2. Okay, so then that means that we multiply our empirical formula by 2. So C2 times 2, and then H5 times 2. So you end up with C4H10. Okay. Okay, so the next part is we're actually gonna be doing stoichiometry. Stoichiometry is just that process of using that chemical equation to sit there and figure out what it is that you need or to add to your solution, or what is it that you can actually produce. So for instance, if we take a look at this chemical reaction, so for every 4 ammonia, we have 5 oxygens, and then that can make 4 nitrogen and 6 waters. Okay, so if we look at the ratio, for every time that we have 5 oxygens, that means there's a ratio of 5 to 4 with the ammonia. Right? We have a ratio of 5 to 4 with the oxygen and the nitrogen monoxide. We have a relationship between 5 oxygens and 6 waters. So that's always going to be the case since we have a balanced chemical equation. Okay, so I'm going to write this down. Okay. What's I know? I keep telling them to buy one, and they won't buy it. So I have to buy it myself. So. I know they're not much. Okay, so now that we have that chemical equation, if we have 3.20 moles of ammonia reacted according to the equation that we have at the bottom of the page, how many moles of water will be produced? So since we know that we have that mole to mole ratio, we have that recipe already, we can use that recipe. So we know that we're going to be starting off with 3.20 moles of ammonia. So in that case, that's what we're going to start off with. That's our given, 3.20 moles. Now, according to our ratios, what is the ratio of ammonia, or according to our chemical equation, what is the ratio of ammonia to water? 4 to 6. So for every 4 moles of ammonia, we have 6 moles of water. So then our moles of ammonia are going to cancel out, and then we're left with just moles of water. Okay. So if we have that much ammonia, how much nitrogen monoxide will we make? So if we have this many moles of ammonia, how much nitrogen monoxide will we make? All right, figure that out. So what's my given in this case?
Work the ratio of 1 to 6 or
Okay, what am I asking for? Read the question. Not the top question, the orange question. How many moles of nitrogen monoxide? Okay, so then that's what we want to get, right? So what is my given? What are we starting off with? What is the question telling me I'm starting off with? So we're going to start off with that, right? Okay, so then the next thing I did was to do what in that first question?
lost.
What was the next step?
Figure out the ratio.
Figure out the ratio. So what is the ratio of ammonia to nitrogen monoxide? 4 and 4, or we can say 1 and 1, right? So 4 moles of ammonia, and we want that to be on the bottom because we want to cancel out the ammonia on top. And then 4 moles of nitrogen monoxide. Fours are going to cancel out. And then, so we're left with just 3.20 moles of NO.
I have lost some question for the kettle.
Okay, and that's typically what happens. If you know what you have and you know what you're looking for, you're just setting it up with the ratio with the two that you have. But the key is you have to have moles. Okay, because if you have grams, you have to convert it to moles. Okay. Okay. Everybody's good? Okay. So this is just, again, looking at stoichiometry, right? So it tells us, you know, if we have our reactants, we can figure out how much of our products that we can make. And they have to be in moles. We have to use that mole to mole ratio. If it's not in moles, we have to convert those moles, those grams into moles, right? Okay, so so how many moles of oxygen is required to burn 2.40 moles of ethane? Ethane is C2H6. So let's write the chemical equation. So what type of reaction is this? It's combustion. Okay, so what do we know about combustion reactions? Okay, so what is our carbohydrate or our hydrocarbon, you mean? Okay, organic or inorganic compound. Okay, so you need something organic. Okay, so we know that that's going to be C2H6. Okay. And what else do we need? Oxygen. And then that's going to make, what are my products? Electric 5 reactions. That type of reaction, so it's always gonna be a product of a hydrocarbon.
Water.
Water. And carbon what?
Monoxide.
Carbon monoxide,
Dioxide.
carbon dioxide. Okay, is it balanced? What do I need to do to balance it? How many carbons do I have on my reactant side? My hydrogens on my reactant side. Oxygens on my reactant side. Okay, product side. How many carbons do we have in my product side? Hydrogens. Oxygens. Okay. Okay, so where should I start? Three next to O. Okay. Oh, three here? Okay. Okay, so then that gives me how many oxygens now? That gives me 6 oxygens. A third from the water. So then that gives me 6 hydrogens. And that's 5 oxygens. How many carbons do we have? We have 2. So I have 2 over here, but I only have 1 over here. So how am I gonna get that balance?
Will there be a 2 in the second on the reactor side?
Okay. So then that would give me how many carbons?
4,
Okay. And how many hydrogens?
12.
Okay.
And instead of the 3 on the oxygen, it'd be 7.
That's 7. Okay.
And then it would be a 6 of the water.
A 6 in front of the water. Okay. So that would give me 12. And right now, that would be 6 oxygens plus 2, so that's 8 right now.
Before,
Okay, so 4 in front of the carbon dioxide. So then that gives me 4 plus 8 for my oxygens, so that'll be a total of 14. Okay, so now we got a balanced chemical equation. So what am I gonna do next? What's my given? 2.40 moles of ethane. And then what is it that I want? I want moles of oxygen. Okay, so then I should be looking at the ratio of what? What 2 things should I be looking at the ratio of? Oxygen to ethane. So how many oxygens do I have to my ethane? According to my chemical equation. 7. So 7 moles of oxygen to how many moles of ethane? 2 moles of ethane. Okay. You guys see that? Okay. So again, don't overthink it. You're given, right? You want to get rid of your given to get to what you want. Okay. And this is just saying what I just told you. So if we're given mass, then we always have to convert to moles, right? So if we're given mass, we always have to convert to moles to be able to use the chemical equation. Okay. So this is just showing you the procedures to go about that. So if you're given mass, you're going to use molar mass to convert to moles, and then you're going to use the mole-to-mole ratio to figure out how much product that you're going to make. Okay, and then you convert back to mass by using the molar mass of your product. Okay, so how many milligrams of nickel 2 chloride are in a solution if 503 milligrams of silver chloride is precipitated in a reaction of silver nitrate and nickel 2 chloride solution. Okay, so the first thing I should probably do is to do what? Okay, so you can probably find the given. There's something that we should probably do before that. What was that? Write the chemical equation. That is correct. We should write the chemical equation. So what do you think is the chemical equation? What are they telling us? What are my reactants? So chloride is a reactant? Do me a favor, read the question out loud for me.
How many milliliters of chloride to chloride are solution of 500 grams of silver chloride in of silver nitrate and chloride.
Okay. So it says precipitating. Precipitating basically means that it happens after the reaction occurred. So would that be a reactant, or would that be a product? That would be a product. So what is the chemical formula for? So that is going to be on the other side of the arrow. Okay. So what is the chemical formula for silver chloride? AgCl. And since it's a precipitant, we know that that's going to be a solid. Okay, so, and then the last part says in the reaction of, so anytime it says in the reaction of, that's typically telling us that those are our what? Those are our reactants. So then what are my reactants? Okay, so what is the chemical formula for silver nitrate? AgNO3. And since it's a solution, we're going to put AQ next to it. Okay, and what about our second one? Our second reactant? Chemical formula. Okay, so what is the chemical formula for nickel 2 chloride?
This could, do I have to add the two on the side of the middle?
If it's balanced, remember, the chemical compounds have to be balanced and have to add up to 0. So if my nickel is a 2+, because that's what you're trying to tell me, nickel 2, right? Because the Roman numeral means the charge, then how many chlorides am I gonna need to balance it out? I'm gonna need 2, so it's gonna be NiCl2, and that's the way I would write it, right? So, and that's also a solution, so what should I use in that case? AQ, that's right. Okay, so then, what type of reaction is this? I'm gonna throw something at you. There are 5 types of reaction. What are the 5 types of reaction? And aqueous ain't one of them. 5 types. Just talked about this last week. It's a double D, it's a double displacement reaction, right? Okay, double displacement. So then who's hooking up with who? Nickel with NO3. And how many NO3s am I gonna need to balance out nickel? So I know it's nickel 2. I'm gonna need 2 of them. Because we know that nitrate is a negative. Okay, now, how do I know if it's a solid, liquid, or gas, or aqueous? Anyone? 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 What would I use? It's aqueous, but why? Yeah. Nope, that's not a good reason. This one is a solid, right? How do I know that that's a solid? Where can I find that information at? Is there something that Dr. Henry has given you that you should be using consistently? That's right, the solubility table at the end of the. Okay, if I put silver and chloride together, what happens? Silver is a solid. And then what about nickel and nitrate? Nickel 2 and nitrate. It's soluble, so that means AQ, right? Okay, is it balanced? No, it's not balanced. What do I need to do to balance it?
Added to the
What's that?
on both sides.
On both sides. Okay. Okay, so now that we have a balanced chemical equation, what are we going to need to do? We're going to use our given. Okay, so here's some important information about it. Okay, so we're going to start off with our given, but it's in milligrams, right? So that you guys know, if I use my periodic table, I can get my units in terms of milligrams per millimole. Okay, so long as the units are millimilla, it works out because grams to moles, right? So that ratio is going to be the same. So I can put it in millimoles by using that same ratio. So how would I find the molar mass of silver chloride? molar mass of silver chloride.
The amount of silver and how much chloride.
Okay, so how many silver do we have? How many silver we have? Okay, so you only want to look at the chemical formula. So you never want to look at the ratio, that's used for when we do the mole to mole ratio. So you only want to look at the chemical formula. So we have 503 milligrams of silver chloride. So that means we have one silver, right? 1 Ag. And Ag weighs how much?
Almost
7.87. And then Cl weighs
35.
so we add those two together. So if we use grams per mole, that's the same thing as saying milligrams per millimole. So it'd be equal to that same value. Long as the prefix in front of the two are the same. So that would be equal to the same thing. So then we could sit here and use the 143.32 milligrams of silver chloride to millimoles of silver chloride. And what is it that we want? What is it that we want?
How many milligrams of nickel chloride are in?
Say that again, please.
How many milligrams of nickel chloride?
So we want to know how many milligrams of nickel 2 chloride. So this is going to give me my moles of silver chloride. So then I need to do the ratio to what in that case?
Ratio of chloride, silver.
Okay, so I need to do my ratio of my nickel chloride to my silver chloride. Okay, so then for every 1 mole of, every 2 moles of silver chloride, I have 1 mole of nickel 2 chloride. Or millimole. Okay, so then my millimoles are going to cancel out for my silver. So now I have my ratio of millimoles of nickel 2 chloride. So if I have nickel 2 chloride, right, moles of nickel 2 chloride or millimoles of nickel 2 chloride, how can I get to milligrams of nickel 2 chloride? What am I going to use? So if I want to go from moles to grams, or millimoles to milligrams, how would I do that?
It's or not.
We're gonna use the molar mass, okay? So, how many nickels do we have in nickel two chloride? We have one nickel. And nickel weighs 58.3356. 693. And then how many chlorides do we have in nickel two chloride? How many chlorides do we have in nickel two chloride? How many chlorides do we have in nickel two chloride? We have 2. So chloride weighs how much? 35.45. And we're multiplying that by 2. Okay, we add them together. Okay. Milligrams per millimole.
Does the compound say milligrams?
This last
It's milligrams, yeah, top. What was that?
This is the last example.
You're responsible for everything that's in the packet. So, even though it may be the last example. Okay. Okay, so there will be a review next week on Wednesday for your final. So since you guys are gonna be taking it And your final's gonna be due at 11:59 p.m. on Saturday, not this Saturday, but next Saturday. If you do not complete it at 11:59 p.m. on Saturday, you get zeros for your final, right? Because that is technically the last day. Can't extend beyond that day. I have no control over it. So you need to make sure that you complete it before 11:59 p.m. I will be putting up, I handed you guys a practice final. I'll be putting up the official final this weekend. On Saturday, 11:59, so you'll have a whole week to get it done. Get it done early, I recommend. Your presentations are gonna be done on Monday, so you need to turn them in on Sunday night, 11:59 p.m. So that I have them on Monday. What was that? It says Saturday? You can turn them in on Sunday, as long as they're turned in by Sunday. Okay, so I said, somebody was here earlier, I said I will be opening all your labs and all your homework. They will be open until the end of the semester, which is Saturday at 11:59 p.m. So everything is gonna be opened up. I'll be opening up everything. That'll probably be later tonight when I get all that opened up, okay? What was that? Formal lab as well, everything. I will be opening up everything. Okay, so you'll have the opportunity to turn it. What was that? The second exam? So that one is due, I think it's Wednesday. I gave you guys till Wednesday, that's last night. So as long as you get it done before Wednesday.